In this tutorial, we will be using a soldering iron, a wire stripper, a ratcheted crimper, a bent angle wire cutters, as well as a pair of narrow head pliers. We will also be using some tin lead solder, so we have a 60-40 tin lead solder here with a 1.8% flux as well as a 0.6 millimeter diameter. We have our soldering iron set to 650 degrees Fahrenheit, but any other type of soldering iron without the digital thermometer will also work. Now it is time for the next step, which is to solder all of the components onto the circuit board. The first component we're going to solder is the SD card. Now the SD card slot is placed on the board in the outline labeled SD1. When placed properly, the leads of the SD card slot will lie flat against the silver pads on the board. Now to solder the SD card onto the board, we're going to take the heated soldering iron and press it down where the component lead from the SD card makes contact with the pad on the board, thus transferring the heat from the iron to both the lead and the pad at the same time. Then we're going to slowly feed the solder into that point of contact that we made between the iron, the lead, and the pad. The heat from the iron will then melt the solder, and the surface tension provided by the flux will allow the solder to flow evenly onto the pad. Once the solder has flown onto the pad in the place where you want it, remove the solder and then remove the iron. The solder will then solidify quickly without the heat and form a connection. Now you're going to want to repeat that process for each of the pads on the SD card all the way along the perimeter until you have soldered all of them. Next, we will solder on the 3-volt coin cell battery socket. The socket will fit into the outline labeled B1 on the board. You are going to solder the socket onto the board in the same way that you soldered on the SD card. The next step will be to solder on the 16 megahertz and 32.7 megahertz crystals. The 16 megahertz crystal, which is the oval shape, fits into the outline labeled Y1, and the 32.7 megahertz crystal fits into the outline labeled Y2, as shown here. After fitting the leads through the holes in the board, it helps to fold the leads on the backside of the board so that the components stay put. Since we will be soldering these components from the backside of the board, this technique will stay the same for the other components throughout this tutorial. After you finish soldering, as a matter of cleanliness, take your cutters and clip the extra component leads on the backside of the board. Next, we are going to solder on the 24-pin IC socket and the two 8-pin IC sockets on the board in the outlines labeled IC1, IC2, and IC3. Now, each socket has a direction to it. On each socket, there is a notch on one end, and this needs to line up with the notch that you see on the outline on the board. Next, we are going to solder in the 14-pin IC bus into the space labeled IC4. This component also has directionality, just like the last three, so make sure to line up the notch on the component with the notch on the board. Now, if this component or any of the other components will not stay in place when the board is flipped upside down, you can hold the component with one finger and hold the solder in place using your thumb to solder the first lead. When the first lead is then soldered, it'll hold it in place, and you can then continue to solder the remaining leads normally. However, if you do this, be careful because heat transfers through the leads from one side of the board to the other pretty quickly, so be careful not to burn your finger when holding the component in place. Next, we will solder the button into the outline labeled B1. However, to get the button leads to fit into the slots on the board, you may need to use your narrowhead pliers to bend the leads a little bit. Next, we are going to install the three LED lights into the slots labeled L1, L2, and L3. L1 and L3 will be red LEDs, and L2 will be a green LED. The LED outlines on the board have a plus sign next to one of the slots. LEDs are polar, so you need to make sure that you insert the positive side of the LED into the slot marked with the plus sign. You can tell which LED lead is the positive lead by looking at the lengths of the two leads. The longer lead is the positive lead, so insert the longer side of each LED into the slot marked with the plus. For redundancy's sake, the LED bulb also has an indicator for which side is positive and which side is negative if you can't tell the difference between the leads. And the way of doing this is by having one side of the rim on the bottom of the LED being flat, and the flat side of the rim indicates the negative side of the LED. Again, when going to insert these components into the board, it helps to bend the leads on the back side of the board so that when you fold them, it holds the component in place, making it easier to solder. After soldering, remember to clean up the backside of the board by removing the excess leads using your wire cutters. Next, we are going to insert the two 22 picofarad capacitors and the five 0.1 microfarad capacitors. The 0.1 microfarad capacitors go here in the rectangle outline labeled 0.1 MF, and the two 22 picofarad capacitors go here in the rectangle outlines labeled 22 PF. First, with the 22 picofarad capacitors, to get these to fit properly into the board, you will have to use the narrowhead pliers to bend the leads to the appropriate width. Once you have the two capacitors fit into place, bend the back side of the leads to hold them in place while you solder. And then clip the extra leads off the back using your cutters. Now for the five 0.1 microfarad capacitors. To fit these into place, you will have to bend the lead on one side of the component so that the two leads on the left and the right become parallel. Then you're going to insert these two leads so that the component is up against the board. And then again, fold the extra leads on the back side of the board to keep the component in place. Next, we are going to solder on the 4 types of resistors. Resistors are labeled via a color code, a banded color code as shown here on the screen. Feel free to pause the video and take a closer look. The placement of the resistors on the board is indicated by 2 slots, one having a circle around it and a label indicating either a 10K, 4.7K, or 2K, or 220 ohms. So to insert the resistors, we will fold them in half, similar to the capacitors, and then place each in its designated slots on the board. Again, here's a reminder on tips for soldering, making a good solder connection. One, make sure that the connection between the iron tip, the hot iron tip, the component lead that you're wishing to solder, and the pad on the board. Make sure that there's a good connection between the 3 of those. And then again, gently feed, or you can imagine pushing the solder into where that contact is, and allow the flux to carry the solder into that joint. Next, we will solder on the IC regulator and the internal temperature sensor. These 2 components look identical, they have identical casings, but are placed in different spots and have very different functions, so be careful not to mix them up. The IC regulator will have the number 1700 printed on its flat side, while the temperature sensor will have the word Dallas followed by 18B20 on its flat side. Now the IC regulator will be placed in the position labeled IC5 on the board, and the temperature sensor should be placed in the position labeled DS18B20 on the board. Next, we are going to solder in the 6-pin horizontal or 90-degree bent header. Now again, just like the IC bus, this component won't stay in place when the board is flipped over. So you will have to hold both the component and the solder in one hand and the iron in the other while you are soldering the first pin. However, after you've soldered the first pin, the component will stay in place and you can continue to solder as normal. Now be careful with this component because the lead is connected on the front and the back of the board, so the heat will transfer from the back of the board on that first pin all the way to the front side of the board, so careful not to burn yourself. Next, we are going to solder in the 3 vertical 10-pin headers. Now eventually, the temperature probes that we made in step 1 will plug into these pins. However, there's a lot of space for the individual strips, these 10-pin headers, to move around. And so we want to make sure that the probes will still fit into these pins. They'll still plug into these pins after we solder. So we can use a completed temperature probe to hold the pins in place before they're soldered, and so that they will be perfectly aligned after the solder is finished. So take a completed temperature probe and plug it into the pins, and then hold them in place. For this step, we will also again have to hold both the pins and solder with one hand and the iron in the other to get the first row set in place. But once the first row is soldered in place, we can then go back to soldering normally. And this is just to make sure that the pins are neatly aligned. And after the first round of soldering is complete, feel free to go over each joint again and clean it up by just adding more heat or reapplying some more solder, just to make sure that these connections are good and solid and that they're not jumping between different leads. Next, we are going to solder on the AA battery holster. This component has two wires, a red and a black. The red wire is for power and the black is the ground. So the red wire will be added to the slot labeled 3 volts and the black wire will be added to the slot labeled GRD. Next, we are going to add the polulu 5-volt step-up voltage regulator. However, before we add it to the board, we need to modify the component a bit. We first need to remove the capacitor on the lower left of the regulator that is labeled with a 100, as I'm showing here in the video. To do this, we are going to take the soldering iron and melt the solder that is holding it on to the small board, and then use the tip of the iron to flick off the capacitor, which will eventually look like this when you get it off completely. Next, take the horizontal 4-pin header that came with the voltage regulator and solder it into the slots on the regulator. Next, we will solder the modified regulator onto the temperature logger. To do this, make sure you line up the lead on the regulator marked SHDN for shutdown with the slot labeled SHTDWN, also for, standing for shutdown, on the main board. So just make sure the two shutdown labels are lined up before you solder. Okay, and with that, that brings us to the end of step 2, where we attached all of the necessary components to the board. In this next phase, in step 3, we will program the board so that it is ready to start recording measurements.